In this video, we're going to talk about the new Dyno view in LinkTools 5. To start with, let's go to our log chart page, and you can see our old standby, the pool that we've been working on here for the last few videos. If we look at horsepower and torque on this view, you can see that they're represented the way they are in ECMLink, which is basically in a time domain. In other words, as time moves along during the log, you're seeing the amount of horsepower and torque represented down here by these traces. That works for the most part, but there's times when you want to look at it in an RPM based domain, which would be like you would see on a dyno, so that you see horsepower and torque based on RPM rather than based on time during a pull. To do that in LinkTools, the first thing we need to do is set some markers as far as the area we want to look at. And the reason that's important will become pretty clear here in a minute. First of all, let's just set a marker here at the beginning of the pull, set the end marker at the end of the pull, and then go over to our dyno page. Now when we click the dyno graph, first thing you notice is that it's arranged by RPM at the bottom rather than time, and you see your torque trace right here in the dashed green line, and then the horsepower in the red line. These are selected over here in the graph display, which is where you can select what you want to look at. You can also view airflow in pounds per minute. You can view your boost pressure, the map signal here. Timing and AFR show up on the top graph. They're scaled a little bit differently, and then you can also look at horsepower per pound per minute of airflow, and we'll get to that in just a second. Now, one thing to notice about this is that over here on the left and right of the graphs, you'll see these colored legends. Those correspond to the trace you're looking at in each graph, so it's a little bit easier to determine what your scale is of what you're looking at. So for example, here on horsepower, up at this point right here, we're right at 400 horsepower and right at 400 pounds of torque, right in that area also. Timing's pretty straightforward, it's just like it is over here in the log chart, other than the fact that it's RPM based now in the dyno chart. Same thing for AFR. You can see right here that with AFR we're somewhere around 12.5 to 1 AFR, which is about right for this log. Now, a couple of things you can do with this. You have maximum markers over here you can click. That will actually show you the location that you hit your maximum torque and horsepower. Up here at the top we have a statistics box. And what this is it's going through, and based on this view that you're looking at, it's telling you what the maximum horsepower, torque, airflow, and map is for this log. So for example, we're looking at 410 horsepower, 6,324 RPM, 395 foot-pounds of torque. There's 50.6 pounds per minute of airflow, and it was at 29.2 psi. It also measures your spool time. If you remember over here, we were talking about the fact that LinkTools, when you import the log, automatically calculates your spool time. It sets markers for the beginning and ending spool, and that's what you're seeing over here on the dyno. It's telling you what that spool time was. It's also measuring 70 to 90 times. So again, on your log chart here, if you looked at your 70 to 90 markers in the log time-wise, this is where you were between 70 and 90, or as close as it can find in this log. Then on the dyno over here, it's telling you what that time is. So it's calculating these things automatically, so it saves you a little bit of work in trying to figure that stuff out. Also, 70-90 times are determined from a smoothed speed signal. Again, back over here, if you look at the speed here, it's a nice smooth interpolated curve rather than the raw data, which makes it harder to get accurate times. So it's still not perfect, but it's a lot closer than what it would be if you tried to guess it at where your 70-90 time was looking at it in ECMLink. You also have averages for the current window here. Basically that's telling you over the entire graph display from 2400 RPM to 6900 in this case. These are your averages for horsepower, torque, acceleration, airflow, AFR, and map. Acceleration is in miles per hour per second, and that relates back to on the log chart when we talked a little bit earlier about acceleration values right here. It's giving you an average value of this over the area in the dyno. Now, one thing you can do here, this is based on the area you have marked in the log. So if I was to come over here to the log chart and move my starting marker up, say to right there, now when I look at the dyno, it's going to shift that, and everything's based on where that marker is. I can also adjust the markers from here within the dyno view, so I don't have to go back to the log chart. That's what these arrows are doing. They're actually moving the marker back and forth in the log chart. Now, something that's interesting to look at here, if you'll notice when I came up to this point, I started getting some really erroneous data showing up. The reason for that is now I'm over here outside of my full pull, and since it's RPM based, it's picking up data from other RPM points out here, and it's blending this data with data back here at the same RPMs. So that gives you erroneous data when you do that. Now there is a couple ways to get around that. One is you just make sure that you select an area of the log with good data where RPM is steadily increasing, so that you're not mixing erroneous data with good data. Now, if I was still under full throttle out here somewhere, or it was a different section of full throttle, the data would be okay. It would average let's say the horsepower at this RPM point with the horsepower at that RPM point here. The reason the data is erroneous here is because I'm off the throttle, so the horsepower isn't anywhere near what it would be here if I was under full throttle. So when you look at it like that, you get bad data out here. So you always want to make sure that you select areas in the log that make sense to view in an RPM based format. One handy thing you can do here is if you don't want to have to worry about finding those locations every time, and you've got your markers set, we first bring the log in, they're like this, you look at the dyno, you get that kind of view, it doesn't do you much good. This is where steady state comes in again. If we go to the steady state tab and tell it to look for all areas that are 100% throttle, like I've got set right here, and show that, you can see that steady state has found that area for me. I don't have to worry about any markers. On your dyno page, if you select use steady state values only, then it will go through and find that data for you. So in that case, all you have to do is import a pull. You don't have to set any markers or anything. Steady state automatically identifies the area that you're interested in. You go to the dyno page and your data is there, and it's all good. So let's talk a little bit now about this horsepower per pound per minute of airflow. This is something I just kind of came up with when I was studying some logs and trying to figure out why my acceleration rate and power always seem to fall off a little during spool, which I understand that it would, but I couldn't quite understand why it was dropping the way it was. And when I added this calculation, I started noticing this dip right here. And what this is basically is it's telling you how much horsepower you make per pound of airflow throughout the entire engine operating range. We've always heard the old standby of 10 horsepower per pound of airflow. This will let you see an actual amount that you're making with your car. In my case, all of the logs I've looked at, I average right around 8.5 pounds or 8.5 horsepower per pound of airflow, except in this one little area where I have this dip. It's interesting. It seems to be related to timing, but no matter what I do with timing, there always seems to be a dip right there. And every car I've looked at, or log from every car, I still see the same type of dip, and it always happens right about the point that boost levels off. So anyway, we're still investigating that and trying to figure out exactly what causes it, but it's a handy little piece of information to have. If you ever wonder exactly how much horsepower you make per airflow, that'll get you in the ballpark. So anyway, that's the dyno view, and in some other videos when we get to them, we might show some other things you can do with this, and get to some new functionality that's coming up in a future version where you'll actually be able to store this for each log and then do some comparisons on multiple logs to find optimum AFR and all that stuff. But that's a little ways down the road. Anyway, hope you enjoy LinkTools, and If you have any questions, holler at me as always, and there will be more videos coming when we get time.